Unit 8.5 is trigonometric ratios. Trigonometric ratios. We're going to talk about the tangent ratio, the sine ratio, and the cosine ratio. If we know two sides of a right triangle and we're looking for the third side, we can use the Pythagorean theorem, c squared equals a squared plus b squared, to solve for the missing side. If we know that it's a 30, 60, 90 or 45, 45, 90 triangle and we know only one side, then we could use the formulas for 30, 60, 90 or 45, 45, 90, find the missing sides. But what do we do if we only know one side, but it's not a 30, 60, 90 or 45, 45, 90? Then we need something else. And that's where these trigonometric ratios come in. So, three trigonometric ratios. The tangent of angle A is equal to the length of the leg opposite angle A over the length of the leg adjacent. You may say, well, where'd that word ratio come from? Well, that's what that is, right? A ratio is a fraction, leg opposite, leg adjacent. Trigonometry, trigonometric, sine, cosine, tangent, ratio. So the tangent of angle A is equal to the length of the leg opposite angle A over the length of the leg adjacent to angle A. Let's talk about that. Here's angle A. An angle is a figure formed by two rays with a common endpoint. Now, one of the sides of angle A is a leg, and one of the sides of angle A is a hypotenuse. The side of angle A that's a leg, we say, is the leg adjacent to angle A because it's the leg that helps form angle A. It is a side of angle A. And the angle across from angle A, we call the leg opposite angle A. So when we're looking at the angle A, then we have a leg opposite it, a leg adjacent to it, and the hypotenuse. The tangent is equal to the tangent of the angle. Notice we have a function, tangent, of an angle is equal to a ratio, leg opposite the angle over leg adjacent to the angle. So we have function of angle equals side over side. Tangent is leg opposite, 3, over leg adjacent, 4. So the tangent of angle A is 3/4. Okay? The sine of an angle like A is equal to the length of the leg opposite A over the length of the hypotenuse. So the sine of angle A is equal to the length of the leg opposite angle A, which is 3, over the hypotenuse 5. So the sine of angle A is 3/5. The length of the leg opposite over the length of the hypotenuse. The cosine of an angle like A is equal to the length of the leg adjacent to angle A over the length of the hypotenuse. So the cosine of angle A is leg adjacent 4 over hypotenuse 5. So cosine A is 4/5. So we have a function of an angle is equal to a side over side. A function of an acute angle is equal to a side over a side. See how those are set up? Function of angle equals side over side. Now, to set up a ratio, notice I have those numbered 1, 2, 3. So the first thing you're going to do is identify the angle. So the first thing you're going to do is find an acute angle. And then you're going to find two sides and see how they're related to the angle that you chose. The two sides that you're talking about, are they leg opposite, leg adjacent? Are they leg adjacent hypotenuse? Are they leg opposite hypotenuse? What are they? This will tell you which function to use. If you're using leg opposite, leg adjacent, then your function would be tangent. So you find the angle, you see how the sides are related to the angle. When you get how the sides are related to the angle, that's going to tell you which function to use, and then the function is going to tell you how to set it up. If your function is tangent, tangent says leg opposite goes on top and leg adjacent goes on bottom. Okay? So we'll put the angle down first, we'll put the function down second, and we'll put the sides down third. Okay? So let's look at this again. To set up a ratio, you're going to find an acute angle. You're going to find two sides, see how they're related to the angle you chose. This will tell you which function that you need. You do what the function says to set up the fraction with the sides. And then you're going to use the order of operations, which is to do anything you can to simplify first and then undo in the reverse order. Sally out during my excuse, please. Now, you need to memorize, as everything else in this book, these trigonometric ratios. I prefer that you just memorize them. Tangent of angle A is equal to the length of the leg opposite angle A over the length of the adjacent leg adjacent to angle A. The sine of angle A is equal to the length of the leg opposite angle A over the length of the hypotenuse. The cosine of angle A is equal to the length of the leg adjacent to angle A over the hypotenuse. Just flat memorize it. Now, since we're in an era of acronyms, and this is kind of a universal acronym for a lot of people these days, I'm going to go ahead and show you the acronym that a lot of people use, just so when you get somewhere and they're not using it, you don't go, well, I never heard of that. Let me clean this up so you can actually see the acronym. Some people use an acronym SOHCAHTOA. That's what they call it, SOHCAHTOA. And it comes from this. Sine is opposite over hypotenuse. And so they put SOH. Sine opposite over hypotenuse. Cosine adjacent over hypotenuse. TOA, tangent, opposite over adjacent. So if you like acronyms, maybe you'll like that. Sine is leg opposite over hypotenuse. Cosine is leg adjacent over hypotenuse. And tangent is leg opposite, leg adjacent. Now, what I don't want you to say is just opposite hypotenuse. Don't just say, so is opposite hypotenuse. It's leg opposite over hypotenuse. Cosine is leg adjacent over hypotenuse. Tangent is leg opposite over leg adjacent. Now, why do I say that? Because people just memorize adjacent to A. The hypotenuse is adjacent to A. Adjacent is not just adjacent. Adjacent is leg adjacent. Okay? So if you use acronyms, don't be sloppy with your acronyms to the point that you make mistakes because you really don't understand what they're talking about. Sine is leg opposite over hypotenuse. Cosine, leg adjacent over hypotenuse. Tangent, leg opposite, leg adjacent. And really, we shouldn't just say that. We should say the sine of angle A is equal to the length of the leg opposite angle A over the hypotenuse. We really shouldn't say sine's leg opposite hypotenuse. We should be specific in the angle we're talking about. Okay, so let's do some examples here. Now I know this looks like a big mess, but we're going to try to follow that step 1, 2, 3, 4. Okay, step 1 was to find the acute angle we're talking about. Well, the acute angle that we know is 40 degrees, so we're going to put down our angle first. Our acute angle is 40 degrees. We fill that part in first. Now, then what we're going to do is see what sides we have. The sides that we have are 6 and x. We want to see how they're related to the angle that we chose. How are those two sides related to the 40 degrees? Well, they're both legs. The x is the leg opposite. The 6 is the leg adjacent. Leg opposite, leg adjacent is tangent. So that tells me to put in tangent. So I found the angle 40. I looked at the sides I'm dealing with. I saw how they related to the angle that I chose. The 6 was the leg adjacent to the 40. The x was the leg opposite the 40. So I thought, which ratio deals with leg adjacent and leg opposite? Well, it's tangent. And then I'm going to do what tangent says. Tangent says that you put leg opposite over leg adjacent. The leg opposite was 6. I'm sorry, the leg opposite was x. The leg adjacent was 6. And so I have my trigonometric ratio set up. Okay? Now let's review just a little bit. First thing we did was found the acute angle. We found then two sides and how they're related to the angle. We said the x was the leg opposite, the 6 was the leg adjacent. We said which ratio uses leg opposite, leg adjacent. That was tangent, so we filled it in second. We made the fraction say what tangent says. Tangent says leg opposite over leg adjacent. Leg opposite x then went on top. Leg adjacent 6 went on bottom. And so we've properly set up our trigonometric ratio. So we get tangent 40 equal x over 6. We're going to bring that down here. Tangent 40 degrees equal x over 6. We're going to do anything we can to simplify. We can do tangent 40. Now, we're in the era of graphing calculators here, so we're going to use the graphing calculator. It's very important here, though, that we have it in degrees. I'm going to move this over here. We're going to go to mode. Everybody see where that's at? See the little arrow? Let me just clear the home screen. I'm going to clear my history, get all that stuff out of the way. You can kind of watch the screen to see what I'm going to do. So we're going to hit the mode button here. We want it on degrees right there, so we have to arrow down. and over to degrees and hit enter. If you don't put it on degrees every time, you're going to have all kinds of mistakes in this section. If you do second plus 712 enter clear, it's going to default it to radians. We'll go over to degrees. When it's blinking on degrees, see it blinking, you hit enter and it locks it in. And then we're going to go back to our home screens. We're going to hit second mode, which is quit. And so now we're ready to go. We want to do tangent 40. So we're going to hit the tangent button. Everybody see where it's at there? I got the mouse hovering it. 40. Close the parenthesis. Enter. And we get a decimal. Now we're going to round to 4 decimal places in this course. So we're going to have 839. That's bigger than 5. So it's greater than or equal to 5. So we add 1. So it'd make it an 8391. Now you can go to float 4 if you know what I'm talking about and make it round to 4 decimal places, but I'm going to have you in your mind round it because I want us to think about rounding. If that's 5 or more, you add 1 to that one and drop the rest off, 0.8391. So tangent 40 is 0.8. Wow, that went crazy on me. Just a second. 0.8391 is equal to 8 over 6. So we did tangent 40. There's nothing else we can do, so it's time to undo. We're going to undo the divided by 6 with a times 6. And so we're going to get x equals 6 times that. So we're going to go 6 times 0.8391. Now we could have left that all in the calculator, but 0.8391 times 6, you know it would be more accurate to just leave that and go times 6 instead of rounding first. We'll round it to 2 decimal places, 5.03. Now I'm doing it this way because when we did the odd answers, we did it using a chart, a trigonometric table of values, which was rounded to 4 decimal places. So if our answers are going to match, then we need to round to 4 decimal places. 5.03 in the work up here, and then 2 decimal places in the final answer, 5.03. Okay? So we found a missing side of a right triangle that didn't have 2 sides given, so we couldn't use the Pythagorean theorem, and it wasn't a 45 45 90 or 30 60 90, so we couldn't use those formulas, and so we had to use a trigonometric ratio. Okay? Number 2. Number 2, we want to find how many degrees x is. This time we're looking for the angle measure. Okay? So the first thing we're going to do is write down the angle measure, x degrees. We're going to look at the sides, see how they're related to the angle x to figure out which function to use. Well, the 13 is the one across from the right angle. It's the hypotenuse. I guess I should have put it there. The 12 is a leg. It's the leg opposite the x. So we have leg opposite and hypotenuse. Leg opposite hypotenuse is sine, so that tells us to use sine x. Sine is leg opposite over hypotenuse. So we put leg opposite 12 over hypotenuse 13, and we have our trigonometric ratio set up. Now we're going to solve. So we say, is there anything that I can do to simplify? And the answer is yes, I can do that division. So I'm going to do that, and I'm going to get a decimal, and I'm just going to round it to 4 decimal places as if we were using a trigonometric table of values. So we're going to take 12, divide 13, and it goes to 0.923. We're going to round it to 4 decimal places, 10 thousandths. That's 5 or more, so you add 1. We get 0.9231. 0.9231. And so we have sine x is equal to 0.9231. Now we've done all we can do. Now we undo. Now this is where we have to think a little bit. When we had x plus 4 equal 8, we said we're going to undo addition by subtraction. When we had x minus 4 equal 8, we said, well, we're going to undo subtraction by addition. When we had 3x is equal to 15, we said we undo multiplication by division. When we had x squared equal 9, we undid the square with the square root. So you undo addition by subtraction. You undo subtraction by addition. You undo multiplication by division. You undo division by multiplication. You undo the square with the square root. But how do you undo sine? Well, what do you call subtraction? You call it the inverse of addition. What do you call division? It is the inverse of multiplication. We undo using the inverse properties. So to undo sine, we're going to use what we call inverse sine. Now, the negative on a exponent reciprocates it. So the negative can mean reciprocal, but that's not what it means here. The negative on the sine function doesn't mean the reciprocal of sine. It means inverse sine. Now, just like addition undoes subtraction, subtraction undoes addition, square undoes square root, division undoes multiplication, inverse sine undoes sine, and you're down to x. You got the junk off of x, as I say it in Algebra 1, by using inverse operations. Now, what you do to the left to undo, you have to do to the right to balance it. So we need to do on the right side over here inverse sine 0.9231. Now, here's where that's at on the calculator. Notice sine is the main button, and hidden above it, see in the blue there, you have sine -1, which is inverse sine. To get to that, you hit the second function button. So it's second sine, which is inverse sine. It opens the parenthesis for you, 0.93, whoops, back up, 9231. Now, what we're looking for is the angle that has that sine value. So we're going to find an angle measure. So the angle measure is 67.38 degrees, rounded to the nearest hundredth. 67.38 degrees for the angle measure. So we can also use trigonometric ratios to find missing angles of right triangles if we have enough information. Okay? All right. Let's look at number 3. Where do we begin? We begin with the given angle. What do we do next? We look at the sides given, see how they're related to the angle that we chose. The x is opposite the right angle, therefore it's the hypotenuse. The 7 is a leg. What is it in relationship to the 50? Well, it's one of the sides of the 50, so it's the leg adjacent to the 50. We have leg adjacent, hypotenuse, which is cosine. So that tells me that my function is cosine. So I have cosine 50 equals something over something. Now I set up my ratio or my fraction with my sides according to what cosine says. Cosine says leg adjacent goes on top and hypotenuse goes on bottom. And so I have cosine 50 equals 7 over x. Now, I'm going to do anything I can to simplify, and so I'm going to do cosine 50. So I go to my graphing calculator, I hit the cosine button, and then 50 close. I'm going to take it to 4 decimal places, 0.642. We're going to round here. We look to the next number to the right. It's 5 or more, so we add 1, 0.6428. We get 0.6428 equals 7 over x. Now, we learned in Algebra 1 that we don't like fractions. And if we don't like fractions, I think y'all learned you don't like fractions before you got to Algebra 1, actually. But what we learned in Algebra 1 was we can get rid of fractions and not have to deal with them. And to get rid of fractions, you multiply by the denominator. Remember that? I think it's page 231 of the algebra book where it teaches that. 230, 231, somewhere in there. I could actually be wrong on that one. But anyway, if we want to get rid of that denominator of x, then we multiply by x to both sides, and it gets rid of it. So my x is, I missed, sorry. My x's cancel there. My 7's still there. I just shot a little high there. So we're going to have 0.6428x is equal to 7. Undo multiplication by division. So we divide by 0.6428. Divide 0.6428. And so you get x is equal to 7 divide 0.6428. And we get 10 point. If we round, that's going to round up to a 9, 10.89. Now, that's thinking of eliminating the denominator by multiplying through the denominator. But let's back up to the point where we did that. We've got 0.6428 is equal to 7 over x. Another way to look at that is to just put that decimal over 1 and solve it as a proportion. If you solve it as a proportion, you would cross multiply and have 0.6428x is equal to 1 times 7, which is 7, which puts you to the same spot, and then you divide and you get the same answer, 10.89. Any questions on that? So we've dealt with an example with a sine ratio where we use one where we use the cosine ratio, one where we use the tangent ratio, and where the solving process was a little different because of where the variable ended up. Sometimes we were looking for the angle, sometimes we were looking for a side, and so we've tried to deal with several different scenarios there. Okay, so that's going to bring us to the daily work. We'll just do some of the top, and then we'll do some various solving at the bottom. The tangent of angle A. The tangent of angle A, remember angle A, it's a figure formed by two rays with a common endpoint. The 13 is the hypotenuse. 12 and 5 are legs. If we think about angle A, 12 is the leg that is a side of angle A. So we say that it is the leg adjacent. And we can see that as A opens up, CB, or the 5, is the leg opposite angle A. Everybody understand how to identify the leg opposite and the leg adjacent? And the one across from the right angle is always the hypotenuse C. So tangent angle A is equal to leg opposite angle A5 over hypotenuse 12. Any questions on that? And then you can go from there. Okay? Let's look at some examples. Uh, let's just do number 8. On number 8, how could we find y? You may take off trying to use a trigonometric ratio, but why? You already know two sides of the right triangle. If you know two sides of a right triangle and you're trying to find the third side, use the Pythagorean theorem. A squared plus b squared equals c squared. Don't just use a rule because it's new. If there's one you already know, that's easier. So we're going to take the hypotenuse y squared equal the legs a squared plus b squared, 6 and 8. Y squared equal 36 plus 64. We're going to do the exponents. Now we're going to add y squared is equal to 100. Get rid of the square with the square root, and we get y is equal to 10. Well, we could get the other side without a trigonometric ratio, but we can't get that angle without it. So we're going to have to do a trigonometric ratio for the angle. So we're just going to put the angle x degrees. Now, what sides do we know? Well, we actually know all three of them. So we just have to pick two of them. Let's just pick the two that were already there, the 6 and the 8, where those are both legs. In relationship to x, though, what are they? Well, in relationship to x, the 8 is the leg adjacent, and the 6 is the leg opposite. Which ratio uses leg opposite, leg adjacent? Well, that's the tangent ratio. Well, what does tangent say? Tangent says leg opposite goes on top and leg adjacent goes on bottom. And so we've properly set up our trigonometric ratio. You see that? Now we're going to follow the order operations horseshoe on page 33 of the Algebra 1 text. Do anything you can to simplify. In the order, please excuse my dear Aunt Sally. Looking for distributive property and combining like terms. We can do that division. So we do it. 6 divide 8 is 0.75. It's 3/4, which is 0.75, and there's no need to put 3.7500. We just leave the zeros off. We've done all we can do to simplify. Now we need to undo. We're trying to get the tangent function off of the x, just like we'd try to undo addition, undo subtraction, undo multiplication, undo division. We're trying to undo tangent. You undo using inverse properties. So we undo tangent using its inverse, which we call inverse tangent. We undo multiplication by the inverse of multiplication division. We undo subtraction by the inverse of subtraction addition. We undo tangent with the inverse of tangent. I shouldn't put a dot. It's not a times. We undo the tangent with the inverse tangent. So inverse tangent cancels tangent, just like division cancels multiplication and addition cancels subtraction. And we're going to have x degrees is equal to inverse tangent 0.75. Now we actually put the inverse tangent in the calculator first. We're going to clear it out. Remember, you have to be in degrees. If you ever hit second plus 7, 1, 2, enter clear, it's going to jump back to radians, and you're going to have to change it to degrees again. So don't forget that. So check to see if it's in degrees. We're going to do inverse tangent 0.75. I like to forgot my numbers, but they came back to me. Enter 36.87 if you round degrees. 36.87 degrees. Any questions on number 8? Okay. Number 11, how long of a slide would you need to get out of a window 6 feet off the ground if the angle of elevation of the slide is 35 degrees? Now, you wouldn't want the angle of elevation of the slide to be too much because it would be so steep you'd plow your legs into the ground and be a little rough on the old knees. So we don't want it too steep. Now, it said, how long of a slide would you need to get out of a window 6 feet off the ground? That means that the window is 6 feet off the ground, and we want the length of the slide x, and we're making the assumption that the building is perpendicular to the ground. So what we have here with the slide and that distance and the height to the window is a right triangle. We've got a 35-degree angle and a side that's 6. If we're going to set up a trigonometric ratio, we're going to start with the angle 35 degrees. We will see how the sides are related to the angle to choose the function. The 6 is the leg opposite the 35. The x, the slide, is the hypotenuse. Leg opposite hypotenuse is sine, so we use the sine ratio. We do what sine says. Sine says you take the length of the leg opposite 6 over the length of the hypotenuse, x. So we have our trigonometric ratio set up. Now again, in this text, we're doing the sine 35, taking it to 4 decimal places. If we were going to be perfectly accurate, we would solve for x without multiplying or dividing or solving anything, and we would get an exact answer. Let me show you the difference, because I really should do it once and get an exact answer. You will be expected to give exact answers as you progress in mathematics. In real life, rounded answers can be dangerous. We're going to go ahead and do sine 35 and round it. Sine 35, 0.5736 rounded. 0.5736 is equal to 6 over x. If we do this as a proportion, if we do this as a proportion, we put it over 1 and cross multiply. So we're going to have 0.5736x equal 6. Undo multiplication by division. And we're going to have x equal 6 divide 0.5736. And we get 10.46 rounded. Now, if you want an exact answer, here's what you need to do. Sine 35 degrees is equal to 6 over x. We would leave it without calculating and cross multiply, and we would get sine 35 degrees x is equal to 6. We would undo multiplication by division. And so we would get x is equal to 6 divide sine 35. And then we would punch that into the calculator, and there would be no rounding as you go, and we could have the exact answer, and then round at the very end to wherever they told us to round to. So we would punch it in like this: 6 divide sine, I lost it, sine 35, there it is. Now, you can see the inaccuracy. We're 10.460. There's a 2 and there's a 6. Now, if we're dealing with long range things or long term things or big numbers, that can cause some discrepancy that could be serious. So, anyway, uh, by doing no calculations until the very end will give us a more exact answer uh, than if we round as we go. So don't forget about things like that as you're solving serious problems. All right? We got some shadow and angle of elevation problems. I'm just going to let you play with those. I think you'd probably need the experience, and there's some fun things built into 14 and 15, and I don't want to just say it because you need to think about it. And so we'll just end this video here and get